Hi, welcome to Padhai Planet, and today in this video we are going to solve this question. The question says that a chord of a circle of radius 12 centimeters, that means the radius of the circle is given here is 12 centimeters, and the angle which is subtended at the center is 120 degree, right? So let's first draw what we have in this question in this figure, and then we will start attempting the question. So suppose this is the center, right? Let me first make the center. So suppose this is the center, and we will connect this like this, right? And yeah, and this is the another radius. So this is the center, right? And this is the arc, right? Find the area of the corresponding segment of the circle, right? So what we need to find out is the area of the segment, corresponding segment. So that means suppose AB is the chord, right? AB is the chord which is forming this, this, which is dividing this circle into two arcs, and this is the center. So that means the corresponding segments of the circle are these two, right? This is one, this entire thing is one segment, and which is called as the minor segment, and the other segment, which is the major segment, that's this one. This entire thing is the major segment, right? So we need to find out the areas of these two segments, right? And this angle is whole of it is 120 degree, and the radius is given as 12 centimeter. So this is 12 centimeter, and this is also 12 centimeter, right? Now let's also name this point, say, as P, and this point as Q, right? So what we need to do is we need to find out the area of the corresponding segments of the circle. So if we are talking about, first we will find out the area of the minor segment. So that's the segment APB, right? So the area of the segment APB will be equal to the area of sector O, A, P and B, right? O, A, P and B, and from this, if we subtract the area of the triangle OAB, we will be left with this area, right? So the point for us is that we find out the area of these two things, right? Now again, we are going to run short in this question of the space. We are going to run short of space, so I'm going to use this space here also. So let's first find out the area of the sector OAPB, right? So that's area of sector OAPB. Now we know that the area of any sector, the formula for this is theta upon 360 degree multiplied by pi r square, right? So this is equal to theta, we already know this is 120 degree, right, divided by 360 degree multiplied by pi is 3.14 for us, so we'll put this, and r square, r meaning 12, so that's equal to 144. Sorry, that's going to be the multiplication sign. Yeah, now this is 3, right, and 3 divided by 144, so this is like 448. So finally it's equal to 3.14 multiplied by 48. So this is equal to, let me take the help from my calculator, and the answer is going to be, yeah, so this is going to be like 3.14 multiplied by 48. So that's like 150.72. This is square centimeter, right? So this is the area of the sector OAPB, and now we will find out the area of triangle OAB. Now to do that, we will first drop a perpendicular from O center onto the chord AB, and we know that whenever there is a perpendicular, right, if this is a perpendicular from O, that's the center of the circle, on the chord, then that means this perpendicular will divide the entire chord into two equal parts. And suppose if this is A, if this is X, then that means AX is equal to BX, right? So now what we will also do is we will consider these two triangles OAX and OAB, right? We will consider these two triangles, which is like OAX. Let's consider these two triangles. Triangle OAX and triangle OBX, right? And we can say that in this, that OA is equal to OB, OX is common, right? And also AX is equal to BX, right? So which means that these two triangles are congruent to each other, right? And if these two triangles are congruent to each other, then that means these two angles, this one and this one, they will also be equal to each other. Then that means each one of them will be of 60 degree, right? And now let's find out, let's look at the triangle OX once more. So that's triangle OAX, and in this we know that sine 30 degree is equal to AX, which is the opposite, divided by the hypotenuse, and that's going to be OA. We already know that, oh sorry, this is sine 60 degree. Yeah, so this is sine 60 degree. So now we already know the value of sine 60 degree, that is root square 3/2, and AX we need to find out, and OA we already know that is 12. So with this we can write that AX is equal to 6√3 centimeter, right? And now similarly we will find out the value of we'll look into the triangle OBX also, and triangle OBX. If we look at in this triangle, then we find that cos 60 degree is equal to OX upon hypotenuse, and that's OB, and this is cos 60 degree is 1/2, and this is like OX. OB is 12, we already know. So from here we can say that OX is equal to 6 centimeter. Now we've got these two values. Now we can find out the area of this triangle OAB. The area of the triangle OAB will be equal to half into base into height, and base is going to be AB, right? So we can say that, you know, AB is equal to 2AX, right? So instead of writing AB here, I will write multiplied by 2AX and multiplied by OX, right? 2 gets cancelled here, and AX is this, so this is like 6 root 3 multiplied by this, because this is OX, so this is this 6, so this is like 36 root 3 is the area of the triangle. And now we will put these two values, this one 36 root 3 and this one, into this relationship, and we will get the answer. So let's put that. So the area of segment APB is equal to the area of the sector, that is 150 minus 0.72 minus 36 root 3. So let's solve it. 36 1.73, so that's like 62.8, 62.28, and finally it will be equal to 88.44 square centimeter. So this is the area, this is the area of this blue part, this part, right? And now we need to find out the area of the major circle. So area of the major segment is area of the major segment. Now that's equal to the area of the circle minus the area of the complete sector, which is again this, right? So that's 150.72 equal to, now area of the circle we already know, it's always pi r square. So putting the value of pi, which is 3.14, multiplied by r square, that means 144, because the radius is 12 and square of the 12 is 144, minus 172, right? So this is equal to, if we solve this, so this will come to 3.14 multiplied by 144, so that's like 452.16 minus 150.72 is equal to, so this is going to be 150.72, so this is 301.44 square centimeter, right? So that's the area of the major segment, right? So this is how we have got the area of both the segments, and I hope you could understand this. Thank you so much. Have a nice day, and bye.